Hi everyone! Hello Ma'am Batukan. In this video, I will be discussing my takeaways of the different finite geometries we have discussed in the class, which includes the 3-point geometry, 4-point and 4-line finite geometry, Fanus geometry, Young's geometry, finite geometry of Pappus, and lastly, finite geometry of disargues. Now, to begin with, we have the 3-point geometry, which has 4 axioms, and these 4 axioms are based from the ebook posted by Ma'am Batukan in our Google Classroom. The title of the book is Modern Geometries by James R. Smart. Now, we have the first axiom of 3-point geometry. There exists exactly 3 distinct points in the geometry. Second axiom is 2 distinct points are on exactly one line. Third axiom, not all the points of the geometry are on the same line. And last is 2 distinct lines are on at least one point. Now, there are 2 theorems of 3-point geometry. 2 distinct lines are on exactly one point. Second theorem is the 3-point geometry has exactly 3 lines. Next is the 4-line geometry and 4-point geometry. So, axioms of these 2 finite geometry are the same, since all you have to do is you can swap points for lines and lines for points. For example, in 4-line geometry, first axiom is the total number of lines is 4. So you change the word lines into points. Second axiom for 4-line geometry is each pair of lines has exactly one point in common. And the last axiom is each point is on exactly 2 lines. So again, change the word lines into points, then you can have the complete axioms for your 4-point finite geometry. Then, because of the axioms that I have mentioned, we have from the 4-line geometry, we came up with 2 theorems which stated that in the 4-line geometry has exactly 6 points. Each line of the 4-line geometry has exactly 3 points on it. And also for 4-point geometry, the 4-point geometry has exactly 6 lines. Each point of the 4-point geometry has exactly 3 lines on it. Now, let's move on to Fanus geometry. What I have learned in Fanus geometry is that it has 5 axioms which stated that there exists at least one line. Second axiom is every line of the geometry has exactly 3 points on it. Third is not all points of the geometry are on the same line. And fourth is for 2 distinct points, there exists exactly one line on both of them. And the last axiom is each 2 lines have at least one point in common. Because of the axioms I have mentioned, so in theorem 1.7, each 2 lines have exactly one point in common. And in theorem 1.8, Fanus geometry consists of exactly 7 points. And also, for Young's geometry, according to the report of Ms. Trono, there are 5 axioms of Young's geometry. So the first axiom is there exists at least one line. Second axiom is every line of the geometry has exactly 3 points on it. And then the third axiom is not all points of the geometry are on the same line. Fourth axiom is for each 2 distinct points, there exists exactly one line containing both. And then the fifth axiom is if a point does not lie on a given line, then there exists exactly one line through that point that does not intersect the given line. So there are theorem of that. So theorem 1, for every point there is a line not on that point. Theorem 2, for every point there are exactly 4 lines on that point. Theorem 3, in Young's geometry, each line is parallel to exactly 2 lines. Theorem 4, in Young's geometry, there are exactly 12 lines. Theorem 5, in Young's geometry, there are exactly 9 points. In addition, we have the finite geometry of Pappus, which was reported by Ms. Capus. So there are 6 axioms for finite geometry of Pappus. First is there exists at least one line. Second is every line has exactly 3 points. Third is not all points are on the same line. Fourth is there exists exactly one line through a point not on a line that is parallel to the given line. Fifth is if P is a point not on a line, there exists exactly one point P prime on the line such that no line joins P and P prime. Now, for the last action, with the exemption in action 5, if P and Q are distinct points, then exactly one line contains both of them. So, theorem of Pappus geometry. So, each point in the geometry of Pappus lies on exactly 3 lines. Alright, for the last finite geometry, we have the finite geometry of these argues, which was reported by Miss Cherilyn. So, there are 6 axioms for finite geometry of these argues. First is there exists at least one point. Second is each point has at least one polar. Third is every line has at most one pole. And fourth is two distinct points are on at most one line. Fifth is every line has at least 3 distinct points on it. The sixth axiom is if a line does not contain a certain point, there is a point on both the line and any polar of the point. Now there are the first theorem is every line of the geometry of this argues has exactly one polar. Theorem 2, every point of the geometry of this argues has exactly one polar. So to sum up all the ideas about finite geometry, a finite geometry, this is any geometric system that has only finite number of points. So in Euclidean geometry, for example, is not finite because a Euclidean line contains infinitely many points. In fact, precisely the same number of points as there are real numbers. So there are two main kinds of finite geometry, affine and projective. In affine geometry, the parallel postulate holds, meaning that the normal sense of parallel lines applies. In a projective geometry, by contrast, any two lines intersect at a unique point, and so parallel lines do not intersect. So both finite affine geometry and finite projective geometry may be described by fairly simple axioms. So, and also I have learned that it is important to familiarize all the axioms from the three-point geometry to three-point geometry hantod sa kang disargues nga mga axioms, since this is very important when mag-proving ta. So in proof, it is important to state the axioms nga maka-prove nga mauna siya, and then the axioms nga mo contradicts siya. So that is very important. And also I have learned that all the theorems, the axioms of the finite geometries are it can be not kanang ma-apply ra siya diha ra taman, but it has a real life kana applications also. So that would be all. Thank you and God bless.